for both Wednesday and Thursday of this week. There have been a few questions on it. Just going to show us a quick sample of some of these things. So hitting start here, and then here it allows me to choose if I want G to be 9.8 newtons per kilogram or if I want G to be 10 newtons per kilogram. It's fairly common when folks are working practice problems for different groups to say, you know what, 10 is easier, like for mental math, things like that. 9.8 is definitely the more accurate and accepted version for what G is on Earth. Since I'm going to be talking to you and trying to do calculations and explaining stuff, and 10 just makes some of the numbers a little bit flow a little bit more smoothly, I'm going to use 10. And then on this one, I said we're going to try to just do the apprentice level and the master level. No need to do the wizard. So I click on begin this level. Going through, going to talk about how to calculate the gravitational energy. That is simply m times g times h. The mass is stated in the problem right there. Different people get different numbers. So you might have 30 kilograms for your mass. You might have something different. And then G on the previous screen before we started to see all this, woohoo, you were able to choose G to be either 9.8 or to be 10. For this one, I chose it to be 10 just to make sure these numbers are flowing a little bit more smoothly. And then H, the height, they tell us here that at top 40 meters for position A. So if I'm going to find the gravitational energy at position A, I just do the mass, 30 kilograms, times G, which for this one we said we would use 10, oh, for cripe's sakes, 10 newtons per kilogram, times H, which is 40 meters. So if we go through and multiply that out, 30 times 10 is 300, times 40, 3 times 4 is 12, and then I've got 3 zeros, 1, 2, 3. So the gravitational energy at A is that 12,000 joules. The kinetic energy at A, we're usually tempted to go through and say, hey, I know kinetic energy is 1/2 mv squared. Some people were stressing here because that question doesn't say, hey, the velocity is, X number of meters per second. But for position A, while they don't tell us it's that many meters per second, at position A, they do say it starts from rest. So that means that the velocity at A equals 0 meters per second. And since we find kinetic energy by doing 1/2 mv squared, well, since the velocity is 0, that means the kinetic energy is 0. So I know the potential energy is 12,000 joules, and my kinetic energy is 0. The last thing that we know from this, it's kinetic energy at A, gravitational energy at A. We now know that the total energy at A is that gravitational energy at A plus the kinetic energy at A. So that's 12,000 joules plus 0 joules. Our total energy is 12,000 joules. Now, that's for this question with 30 kilograms there, 40 meters there, and G being 10. If you have different numbers there, you're going to have to plug them into the equations a little bit differently. But that's the total energy at A, and everything is in our system, so that means that's the total energy at A. That also means that it's the total energy at B. So these two should add to 12,000 total. And it's a closed and isolated system, so that means that these last two should also have the same total energy. Energy is both conserved and constant. Total energy there should be 12,000 joules. So that 12,000 joules of total energy is how we're going to find the kinetic energy for parts B and C. So what we can do at part B, for part B, I can now say, hey, the gravitational energy at B is mgh, and I know the mass is still what it was, 30 kilograms. G, I'm still using 10 newtons per kilogram. And H, we have a new H. The height at B, they say over here, is 18 meters. So now we can go through and do that calculation to find that gravitational energy. And so I take 30 times 10 times 18 and punch that into my magic calculator, and I get 5,400. Kilograms cancel with kilograms. I get Newton meters. Same thing as a joule. So the gravitational energy at B is 5,400. 5,400 joules. Now, again, your version of this question might give you a different height, might give you a different mass, and you might choose 9.8 instead of 10. So your number might not be 5,400, but this is the process to find that gravitational energy at B. And then the kinetic energy at B, well, we can say total energy. I'm going to say ET for energy, total, equals EK plus EG. Excuse me. So EK is what we're trying to find. So that means I want to get EG out of this side and to the other. Excuse me. So I can say kinetic energy is energy total minus the gravitational energy. And the total energy is constant for this system, so 12,000 joules. The gravitational energy, we're doing B, the gravitational energy at B is 5,400 joules. So if I do 12,000 minus 5,400, punch that into our calculator, and I believe we get 6,600 joules. So if I add this together, I get the same total as that. And we use that same process for part C. So part C, we find that the height at C is 0, so the potential energy is 0, and we use the same total energy process to find the kinetic energy at part C. That should do a pretty good job of setting us up for getting this problem done. And that should do a pretty good job of setting you up for the next question as well. Good luck to you, folks. Send me an email if you have any questions.